Well, hello, friends. Today we're going to work a little bit on security in Serenity because I've been doing a bunch of that over these last few days, and I just noticed this big security problem, and I thought I would record solving it. So the issue is about the local sockets in the system, because everything uses local sockets to communicate. Like the terminal program connects to the Windows server with the local socket, and then programs that want to play audio connect to the audio server, and so on. And all these local sockets are in temp portal. And if we look at these, we can see that they are all owned by root, and they are all writable by everyone. And that's a bit weird because if we look at Windows Server here, for example, we can see that Windows Server is owned by, the processed Windows Server is owned by user 100, which is me, Anon. And the fact that it's writable by everyone is not very good, because that means that we can just switch to another user like Nona, which is a test user that I have. And I'm still able to just start apps and they connect to Anon's Windows server because it's world writable, and we should fix this. And there's this other issue as well, that these RPC sockets are also world writable, so everyone can connect to everyone's RPC socket. And what these are used for is there's this tool called the inspector, which allows you to connect to a running program. And I've shown it many times before, but let's just connect to something. So like Windows Server is PID 12, so we'll do inspector 12. And it allows you to connect to it and just look at the internal state of the program, which is nice if it's your program. But, oh, and then we died because of something. I don't know why. Did we assert or something? Here, yeah, something. Maybe that will come up again. But anyway, you are able to inspect something that's not yours. So, for example, system server. This guy right here is PID 4. We can connect to it, and if we look in temp, we can see that this RPC socket, RPC for PID 4, is owned by root. And this is basically a view into a program that root is currently running. And, you know, this is just using a homemade RPC protocol where we ask for JSON representation of what's live in the program right now. And then the idea is that you should be able to add like RPC requests and stuff like that. But the fact that we can see internals of this program here is clearly not right. And, you know, if the RPC mechanism itself has some bug, then we might be able to connect to that socket and overflow some buffer or something, who knows, and get it to do something that we don't want it to do. So the fact that these are running world writable is not right. So we got to lock it down so that these are only writable by the user. And then also these portal sockets, I think we should make sure that they are owned by the user that's running that process, because the non-privileged user, this user Anon is running all of these programs that correspond to these sockets. So we got to make sure that that's lining up. So maybe we can start with the Windows server, audio server, those things. So if we look in the system server main, I guess. So this would be in the service class, I guess, where we create these sockets, right? So we're passing these sockets to the child process. So we're still in system server here. We start up a service, and it's actually when someone connects to the socket for the first time, then we'll spawn the child process and then transfer the socket to the child. So let's see, spawning, and do the socket takeover thing. So file descriptor number 3 in the child process will be a socket to take over. So I think what we need to do is, here we are changing the, we're dropping privileges here. So we're going from root, from UID 0, GIT 0 to whatever is configured for this particular service. So if you look in the system server config file, we can see here that Windows Server, for example, runs with this socket and user anon, right? So we want to change all of these servers here, or we don't want to change the config, but we want to make sure that the socket is owned by this user as well. I think that makes sense. So let's see. I guess we should set it up to be owned by that user actually. So set up socket. So after we create the socket, wait, how the hell do you set the file mode of a socket? I guess we can fchmod. So fchmod. We want to set it to 06, only readable and writable by the owner, and then fchown. UID and GIT. All right, so I think we'll do something like this. We'll refuse to continue if we can't change this. So assert not reached. Mod. Okay. And will this just work, I wonder? I have a feeling this is not going to work because the socket doesn't correspond to a file at this point. I mean, we know that it's a local socket, but we've never told it where to go in the file system, so I feel like that's just not going to work. Fchown, invalid argument. Right. So what actually happens is fchown. I guess we go to chown, and then we get invalid argument because the file description does not, this FD does not point to a socket. So, shit. And I bet if we look at chmod, it's the same story. Yeah. So chmod, same story here. Because it's, the underlying file is not an inode, then we say bad F. So let's put these next to each other, and because I think we're going to want to change both of them. Chmod is such fchmod. I don't know why it's called that. Let's change it to chmod. But I think we want to delegate this job to the underlying file in the file description. So we'll just say chmod mode. And we'll let the file take care of it. And same with chown. So return m file chown mode. No, not mode. UID GIT. And then we'll have to add these to the file base class. So let's just say chown. And maybe we'll just say ebadf if you call this on somebody who doesn't support it. Chmod. Or I wonder if that was like the right error return or something. These error codes, standard Unix error codes, are so like ambiguous. Here we need a mode T. All right, so first thing we'll do is we'll just restore the old behavior by implementing these in inode file, which is the file subclass that implements inode-backed files. Just a regular file in the file system, basically. So this will be like this, inode file. Okay. We'll maximize this, make it a little bigger. Did not get so much sleep today. Have to get my clock back in order before work starts up again after the holidays. So doing a little bit of that. So now we just want to do what Sean was previously doing here. If we had an inode, so just this. And chmod, just do that. And then let's see, we can do that and that. Okay, because file description always has an underlying file, so that's nice. Then we can go and implement these for local socket as well. Because I think it's when we bind, that's when we get a file. Yeah, right. So here in local socket bind, that's when we open up and actually create the socket file. And we're creating it 0666. That's not very smart. That doesn't even sound like the same behavior, to be honest. Maybe it should, well, I mean, I don't know. Maybe it should at least just respect the process umask. We'll do that. At least it's like some mitigation. Because the default umask is to just remove the write bits from permissions on new files. So this will make them not writable, but you'll still be able to read from them. I wonder if that would prevent you from connecting to it, though. I don't think it would. Because here's connect, and connect doesn't appear to look at the... actually doesn't appear to look at the permissions of the thing that it's connecting to. We might have to look at that as well. We'll see what happens when we like set up the right permissions. We'll see if it's still possible to connect, because maybe it doesn't even do any checking. It's been really fun these last few days, just hunting down all these Unix security problems in the system and trying to fix them one by one. And I mean, just doing work like this, right? Add file number service 99. So, oh wait, hold on. Do I have to rebuild something? Fachone. I can't fachone. Did I just not do anything with that? Oh, I didn't implement the local socket thing. Right, of course. Okay, results. Shown. And chmod. And since we don't have a file until we call bind, so when you create a local socket, first thing you do is you just call socket, right? Socket syscall. And it gives you a file descriptor that refers to a local socket, but it doesn't have a file name yet. So between socket and bind, so this whole range here, there's no file. So we can't just assign these to anything. We're going to have to store them, stash them basically in the local socket object, I think. So we'll just store them right here. Pre-bind mode, maybe? Something like that, or I don't know. Maybe that should be the default mode of sockets, actually. Pre-bind UID and pre-bind GID. Let's populate those somewhere. Maybe where we construct. So local socket and the constructor will do pre-bind UID is current process effective user ID. Or maybe the user ID actually. I'm still a bit confused about the effective user ID versus the user ID. I think the effective user ID is what you use when you're verifying permissions and stuff, but it's not what you would propagate. You wouldn't propagate it as the UID of something that you create, I think. But I'm catching up on so much security stuff. I haven't been paying attention, and this whole thing has kickstarted something, but it is really fascinating. So, I mean, it's fascinating how it's become like this cool culture around essentially bug hunting and unit testing. Very, very glorified bug hunting and unit testing, and I'm very grateful for that. And you know, if we play along here, then maybe we can get some help to find some more interesting bugs. It seems like a worthwhile game for everyone, right? So let's say that these are the default pre-bind settings. And then when we do bind, let's actually then say we pass the pre-bind mode. And I guess if it does open, result, what is this M file? And then we gotta do M file chode. Where do we do that? Fix me. Is this a tuck tool? Because I'm not passing the UID and GID to open here, so it will start out creating it with the credentials of the current process, and then we will change it to be the credentials of the pre-bind credentials. But I feel like that's clearly wrong, so let's not even go there. We gotta make sure that we pass in the credentials. Also, this thing is getting so chunky. Let's just take him down a notch. All right, so I guess we can. We have to pass in. We have to pass in the UID and GID that we want. So let's say functional UID and GID, something like this, and okay. So we'll take one of those, and then, but everyone will know that by default you don't need to pass them. Open optional uid and gid. And if we have to call create, we can just pass it on. So creds. Or actually, it's not really the credentials, it's the owner. Okay. And it's only relevant when we create a new file. So let's follow this rabbit hole. Create, oops. Okay, so VFS create gets a optional uid and gid owner. Where are we passing in the frickin' owner info? I guess we're calling create inode, but where is the, oh shit, it's just choosing like this. Also, it's choosing the EUID and EGID. I'm not even sure that's right. Well, frick. I guess we have to, I guess we're going to have to modify the syscall so that it takes a UID and a GID. Or not syscall, but this file system thing. That's okay, we'll just include it. UID and GID T. Okay, this will be great. So here, just do that. Actually, it's not so bad. Oh, and we have to take it in create directory as well. Well, this will be good. This will be good for us. Good. Okay. Good. And then we have to do the same for create directory also, actually. So maybe this can be a patch of its own, actually. I hope that would be really nice. Let's do this in a separate patch, because it just seems worthwhile in general. Tempfs. What is this? mknod. I think for all of these we can just help it along here and just say current process UID current. Okay. Yeah, I don't feel confident that it should be the effective user ID, so I'm changing it. I need to go and look that up later, but it should be harmless, I think. Because at least it reduces the chance that we would create a file owned by the super user rather than by ourselves. But I don't know. I have to look into how this is supposed to work. Current process good. Current process good. Okay, let's close everything. Guess we have some more. Okay, what are you doing, computer? OK. And then we go and change the sky as well. Thankfully, most file systems don't support file creation yet, so don't have to worry about that. Of course, we'll get there sooner or later. We gotta have more file systems than this. I have to look through the file system code layer to see that it's doing the right thing. I'm sure it's not doing the right thing everywhere, you know. Okay, there we are. Can we just build this, please? And just forgot to save. All right, take me to the mistake I made. Okay, order, unused. Right, so this is the thing that we're supposed to change. As value, if so, owner value, UID, otherwise this, and same thing for a GID. Okay, and this is how we propagate the information to the underlying file system. Right, local socket. We didn't actually implement chown and chmod. So local socket chown. Let's say that if and file, if we don't have a file, that means that we are in the prebind state. So prebind UID, prebind GID. Like, should we validate these? I feel like we should validate these. It's kind of weird if we don't. Maybe we'll do it this way instead. If we have a file, then we'll just return and file chown UID GID. Okay, wait. That's not going to validate either, is it? It will call chown. Oh, which actually goes and checks on this. Wait, what is this doing? Checking. All right. I think we have to validate it. That's a good thing. So if if is superuser or current process effective user ID is UID or current process in group GID. Wait, hold on. If you are the super user or both of these are true, we'll require both. Okay, that sounds sensible to me, so we'll say it like that. Or we can flip it around. If you're not the super user and the UID doesn't match or the we're not in the group. Then we'll return eperm. Otherwise, we are good. Okay. What is the thing? Okay, success. Right. Right, chmod as well. Chmod. So let's see if we have a file already. So we've bound. Then we will just delegate to the file. Otherwise, what do we normally do? We mask some bits, right? Only change the permission bits. Yeah. Let's just make sure that we only do that. Don't care about any of the other bits. All right. M prebind mode. Mode and that, and return case success. All right, program. Let's run. Okay, that did not go well. Bad FD number. Okay. Well, I'm sure that we have introduced this problem. Where's the first failure? So here, the first thing that happens is the menu applet tries to connect to the Windows server. Maybe we can run it in, oh crap, what's it called? Text debug? Is that it? Just give me a, wait, what? I can't even type here? Can I type here? Oh, that didn't go well. Seems like the text mode is not super maintained at the moment. Are we not starting a shell for this? I mean, I guess if we do this, then there's no system server. So what happens then? Bin shell. Let's just start a second shell. Let's see what happens. Oh. Wait, the shell dies. Read failed, bad FD number. Why do you die, bro? Okay, did we... I don't even know. I've changed too many things now. Got so carried away with the changes we were making. So maybe we got a little too happy with the prebind mode. Let's just say that we prebind at 666. Everyone can write to the frickin' socket. And it still doesn't work. All right. File description. So we're getting bad F. But who's giving us bad F? Okay, so what if we didn't do these things? What if we just left it alone? I feel like these default values are not unreasonable. Okay, so if we leave it alone, we start up fine. Then the problem happens when we do the prebind. So what if we only change the owner? It still works. Okay, so let's go and look at what we have now. So now, at least they're not writable. This is owned by root, but what about these guys? They're still owned by root. So this does not appear to have worked. For chown, and then for chmod, that just worked also. No, that does not work. Okay, so if we chmod them, then we get connection refused. Let's see why. So I guess it's here. We're trying to open the address. Or here. If we don't have a socket on that inode. Or if we are still not connected after having blocked. Okay. So open failed, con refused. Let's see which one this is. This is no socket, and what was the last one? Not even connected, bro. All right, which one is it? Open failed, connection refused. All right. So open fails now if we chmod these guys. And why does that happen? When we bind these, we're passing in the sock. Okay, let's say mode. Mode is find local socket with mode. Let's just print this octally. Okay, so we're binding these presumably with this mode. I guess the problem is that they're still owned by root, and that's why the anon user cannot connect to them. So when we are creating here, oh right, because we're not passing in the freaking credentials. Duh. Okay, so prebind git, prebind git. Okay. let's see. Owner. Okay, so say UID and GID owner. No, still no good. And owner. And oh, too fast. Okay, so we are using owner 0. Why is that? Binding the local socket. So we're calling Fachon on the socket with the UID and the GID. Is this computed later or something? Resolve user. Yes, we should set up the user first before we create the socket. All right, so that's a problem within the system server. Okay, because I guess we were just passing in 0. All right, here we go. So, portal, TMP portal. Finally, these are starting to look kind of reasonable. So these are now only accessible to me, the non-user. So if I were to change to root, I can still start a text editor because I'm root. I can do whatever I want. But what if I become Nona? I am refused a connection. That's awesome. So it means that I can no longer connect to the Windows server. I think actually I can't even do a host lookup either, because that will try to connect to the lookup server. And none of it is allowed. So this is very good, very good. Good progress. Of course, now we still have all of these RPC sockets for the inspector. And I think if we wanted to inspect number 4, we can still connect to it, yeah. And that's not supposed to be like that. So we definitely want to change that as well. And we die when we exit, but that's some other issue. So let's see about the file system changes first of all. If we can just isolate the passing UID and GID. So file system.h. And TMPFS. And is any of this about, oh wait, init, we didn't need that change. That was just trying to get another text terminal, but it seems like that's not really working right. But the rest of this is not, well, this one is actually. File system, virtual file system. Okay, so kernel pass allow passing initial UID and GID. I'm creating new files, new items. We don't. If we are creating something should have a different owner than the current processes UIGID. We need to plumb that all the way through VFS down to the file system functions. Okay. And then, let's see, then we have the local socket changes. So I guess I'm just gonna close everything here. Okay, so local socket, it's debug text we don't need. And this change is making it possible to chmod and chown a local socket. Oh, hold on, not you, system server. Oh, make it possible. Chmod and chown a local socket pre-bind. Pre-bind in unbound local. Allow chmod and chown on a pre-bind local sockets. In order to ensure a specific owner and mode when the local socket file system endpoint is instantiated, we need to be able to call fchown-mod and fchown on a socket fd between socket and bind. This is because until bind, there is no file system inode for the socket that we can do this to. For the socket. Okay. Until we call it. Okay. And then system server. Set the owner UID. Gid. Make service sockets owned by the UID by the service user. Configured user. Yeah. Also make the sockets readable and writable only by that user. This fixes a bug where anyone could connect to anyone else's services. Most obviously Windows Server. Okay, now let's do that RPC thing. So what the heck was that? It was the fact that these are still readable by everyone, because I guess we don't chmod those sockets at all. So the RPC code is provided for anyone who uses a C event loop driven main loop in the program. So it's this RPC client objects instantiated whenever someone connects to the socket. And the socket itself is opened here. So this is the RPC path in the C event loop constructor. We unlink it if we had it some before. And then I guess what we call listen is probably when we set this all up. So I think we're just gonna say that C local server by default. I think this is same default. We'll just chmod the MFD 0600 so that only the user who owns this socket can connect to it. Pierre, and then let's also not tolerate. Let's not tolerate if that doesn't work out, because we don't want to be sitting there with a world readable, world writable socket. I think. Of course, in this case, we don't have to care about the UID and the GID because we are not root. We are just running this as whoever started this particular app. So system server is a bit special because it runs as root and then it drops privileges for each service that it spawns. But here we're just running as the intended user from the beginning. Oh wait, I forgot to sync. All right, so what do we have now? Boom. Look at that. Isn't it beautiful? We should not be able to connect to PID4 anymore. Connection refused. That's very nice. Well, what if we root them? Then we still can. That's very cool. Then when you do that, then it, what is it that dies actually? System server dies. Oof. Ref count. Maybe that's something stupid that we're doing. Construct an RPC client, and who is dying? This RPC client is being destroyed. Okay. Is there someone calling delete on itself or whatever? Yeah, that is quite a hackish way to clean yourself up. It's so hackish that we're crashing, in fact. I think I never updated this after I made CObject reference counted, which was quite some time ago. So first off, we'll say libcore. Make the C event loop. Make the RPC sockets. Stop making the RPC socket to group and world read. I guess we can say it like this. GW is, or is it GO? Group and other is RW. I think that's how you type that, right? Now that we can chmod on a pre-bind socket, use that to prevent the RPC sockets published by each libcore program, by every C event loop driven program from use that to prevent the RPC sockets published by every C event loop driven program, prevent them from being, oh god, this sentence is so not nice. Use that to lock down the RPC sockets we publish in all C event loop driven programs. Ugh. Okay, so we can't just call delete this on a C object like this. Instead, because what we're doing here, like when someone connects to us, we're ready to accept, so we accept the client to the RPC server, and then we construct an RPC client object, and then we leak it, and then in one of the callbacks in the client, when we get told, hey, this client has disconnected, time to shut down, we call delete this, but this doesn't work. So let's instead put this in a hash map. So we'll make a hashu mapu. Hash map of what exactly? I guess some kind of a client ID to a ref putter to RPC cliento. Okay, class RPC client. There we go. And then when we construct one of these guys, we'll just say RPC clients set my client ID, this. And my client ID is going to be, I don't know, client ID plus plus, whatever. Fix me, this can wrap around. It's not great if this wraps around. We'll call it maybe next client ID. Right. Alright, and we will say here something like that, and then we can just delete it from the map. Remove mClientID. So now when we get told to shut down, we will remove ourselves from this hash map using the client ID, and this hash map keeps us alive because it's the only thing keeping us alive because it has a reference counting pointer to us and the client. I just gotta be a little bit cool here. So the constructor of this thing will put it into the map, so we don't have to worry about it. I think this will work. Actually, we can delete that line there. We can even simplify. Look at how simple it gets. That's pretty cool. Just hurry up. Everything good? Okay. Well, let's run it and see what happens. So, can we crash the system server once again by inspecting it? Connect to it and then disconnect, and the system server did not die this time. Although maybe we don't have to dump this out on the debugger, but yeah, it's not the end of the world. Pretty cool. So now we can inspect our own Windows server, for instance, perfectly fine. Disconnect, nothing falls apart. Oh, that's great. Okay. So libcore fix crash on RPC client disconnect. The RPC server client management is not updated for the changes that I've made. C project reference counted. It seems. Okay. Great. So I think this is going to be it for today's video. So if you made it this far, then I thank you for watching and for hanging out with me while we lock down the local sockets in the Serenity operating system. So isn't that nice? Now we can't connect to these if we are somebody else. Let's become the poor Nona. We cannot make a connection to the Windows server. Can we change the volume? Perhaps mute? We cannot mute. Will this just try forever? It seems like we should give up at some point. Well, we don't have to solve everything at once, but we should probably give up at some point here. But yeah, this is pretty cool, right? So we can actually, we have 2 processes running here that are ours. So what can we learn about those? 24. I don't even know what those are. Seems like we are creating some of these and then leaving them around. Why are we doing that? Why don't we clean this up when we die? Well, I don't have to solve everything right now, but it's pretty nice that you can now be sure that nobody will connect to your Windows server, nobody will connect to system server, especially. That's the one that was spooking me the most, because the fact that we have a service that's running as root was listening on the socket, and I didn't even realize that this was happening, and you could connect to it, and as you could see, it had like this goofy crash bug and everything, and I'm sure that it has more bugs, so it's really good to lock that down. Now only root can connect to it. So yeah, very cool. Of course, if you like this type of stuff, and you like investigating these type of things, then you're very welcome to help out and look for other issues in the system. I'm very interested in any kind of correctness bugs, really. But anything where you can kind of lock down the system in a way that doesn't interfere with normal operation and in a way that doesn't get in the way of day-to-day use, really. I'm very interested in that type of stuff. So I'm really happy if you like that type of stuff, if you get in touch. As always, you can find me on IRC and through the other communications channels and whatever mentioned. But you already know that if you're already involved with the project. So, but yeah, this is pretty fun. So thanks again for watching, and I guess I will see you next time.